Your AI agent sounds smart, but is it fast, correct, or consistent? Or does it just feels like it works? In production, vibes don't scale, numbers do. Introducing testing and evaluations in AI voice agents. Let's break this down from scratch. At its core, every voice AI agent is just 3 systems chained together. Speech to text converts audio into text. A language model understands intent and generates a response. Text to speech converts that response back into audio. That's it. Most teams only test. Does my agent respond? Does the audio play? But in production, what actually matters is, how long did STT take? How long did the LLM take to reason? How long did TTS take to speak? What was the end-to-end latency? Was the response even relevant? Without measuring this, you're shipping blind. So the real question becomes, how do we evaluate voice agents scientifically? And we have solved this at Video SDK. Now let's jump into the coding part and see how it works. We start by importing the evaluation and component primitives from the Video SDK Agent SDK. These imports define the evaluation runner, individual test turns, latency metrics, and the STT, LLM, and TTS components that will be benchmarked. Next, we'll implement a function tool to check the weather. We create an evaluation object to configure the metrics and reporting for our tests. And within this evaluation, each turn represents a single, complete execution of the agent pipeline, from input through STT, LLM, and TTS, including optional tool calls and judging. Now let's start testing the agent. First, let's see the scenario 1, where we will test the full pipeline by running STT on an audio file, feeding a mocked prompt into the LLM with tool access, generating mock TTS output, and using an LLM judge to assess response relevance. STT uses a fixed audio file via file_path. The LLM is configured with a specific model and either consumes STT output or a mock_input to control variability and enable tool usage. And TTS is set to either speak the LLM output or a fixed mock_input, like the tongue twister here, to measure synthesis performance independently. In the second scenario, each component consumes the output of the previous one, with STT feeding its transcription into the LLM and the LLM's response being passed directly into TTS, making this scenario useful for testing real production behavior, true end-to-end latency, and overall response quality. In the third scenario, components are tested in isolation by running STT, LLM, or TTS independently, which is useful for benchmarking individual performance, identifying bottlenecks, and validating each component. Now let's run the file and see how the evaluation executes and generates structured output reports with latency metrics and judge scores. This output shows per-turn latency metrics at the top, followed by detailed logs for each evaluation turn, including STT transcripts, LLM inputs, agent responses, and judge results. The LLM-A's judge explains why a response passed or failed and assigns a score, helping us analyze both performance and response quality across different scenarios. And that's a look at how AI voice agents work under the hood. By testing and evaluating each part, listening, reasoning, and speaking, we can catch errors early, measure performance, and ensure the agent responds accurately and naturally. Check out the docs, and if you're building with us, join our open source AI agent community of 5,000+ developers and start building today.